The following is a selected video from masterthecontent.com, where you will find an extensive video library of lectures for a variety of standardized admission tests. We offer over 600 hours of detailed video lectures for a multitude of standardized tests. Use our interactive in-lecture table of contents to find specific topics of interest. Work through numerous in-lecture examples to help you internalize concepts. To learn more, visit masterthecontent.com. Your career, our passion.
Acid-base properties of salts. So firstly, what is a salt? So when you have an acid neutralizing a base, what ends up, the resulting ionic compound that's formed, that is the salt. Okay, furthermore, a salt can also be an acid, a base, or it could be neutral, it could be acidic, or it could be basic. Now, getting to the reactions, if you have a strong acid and a strong base, you're going to end up with a neutral solution. Furthermore, when you have a strong acid and a weak base, you end up with an acidic solution. When you have a weak acid and a strong base, you're going to end up with a basic solution. Now, the following ions in pure water form neutral solutions. When you have and let's look at the bases first. The strong base cations from group 1, it's going to be the lithium, sodium, and the potassium. From group 2, it's going to be the calcium, strontium, and the barium. Furthermore, the strong acid ions that form neutral solutions is going to be the chloride, bromine, iodine, the nitrate, and also we're dealing here with the perchlorate. Great. Let's actually do an example of this, and we'll do that on the next slide. All right. Okay, example, predict if salt solution is acidic, basic, or neutral. Predict whether the solution of the salts will be acidic, basic, or neutral. All right, so let's begin here with potassium chloride. Well, potassium chloride, the salt potassium chloride is formed from a strong base, potassium hydroxide, plus HCl, a strong acid. Thus, our solution will be neutral. Now, if we take a look at the next one, right? The salt sodium chloride is formed from the strong base sodium hydroxide plus the weak acid hydrogen fluoride. Thus, we're going to end up having a basic solution. Now, if we take a look at the next one, here we have sodium bromide. And because this salt is formed from a strong base and a strong acid, we are going to have another neutral solution. Wonderful. Now if we take a look here at potassium cyanide, well, the salt potassium cyanide is actually formed from the strong base, potassium hydroxide, plus hydrogen cyanide, which is a weak base. So here we'll have another basic solution. Great. Next we have here ammonium iodide, and that salt is formed from the weak base ammonia plus the strong acid hydrogen iodide. Thus, this solution is going to be, you guessed it, acidic. Now we have here barium chloride, right? And the salt barium chloride is formed from the strong acid barium hydroxide plus hydrochloric acid, and we know that's a strong acid. So when you have a strong acid and a strong base and a strong acid, then we're going to have a neutral solution. And again, we're just following what we talked about on the preceding slide right here. Great. So now let's go off and finish off here. We have zinc nitrate, and that salt is formed from zinc hydroxide zinc hydroxide, which is a weak base plus a strong acid and nitric acid, and that, because we have a strong acid and we have a weak base, we are going to have a acidic solution. Okay, great. There we are. Wonderful. Now we can move on to our next slide. Perfect. What are we being asked here? Example, finding the pH of a basic solution. What is the pH of a 0.2 molar solution of sodium acetate? Okay, well, we know that the sodium acetate is going to dissociate completely. Then what happens? Well, let's write down the reaction